Across billions of years, life has been whispering, humming, shimmering, and signaling its way into connection. From the first chemical murmurs in ancient oceans to the vibrant languages of birds, mammals, and ourselves, communication has shaped every corner of the living world. Hello there, and welcome to the Late Night Scientist channel. Tonight, we'll drift through that story, slowly, calmly, watching evolution discover new ways to speak, listen, deceive, reassure, and imagine. Settle in, breathe deeply, and let nature's long conversation guide you toward rest. We begin in a world without messages, only reactions. Molecules drift, collide, and occasionally cooperate. Communication does not yet exist, but responsiveness does. The chapter frames communication as an emergent property, not an invention. Gentle humor. Evolution hasn't started talking yet. It's still clearing its throat. The story of communication begins long before anything had a voice, or a nervous system, or even the faintest idea of wanting to express something. It begins in a vast and restless ocean under an alien sky. The young Earth is not yet the quiet blue marble we know today. It is a rolling planet of volcanic breath, molten exhalations, and a ceaseless churn of tides. And yet, hidden beneath the turbulence is a kind of calm, the slow, patient chemistry that will one day give rise to life, and eventually to the first whispers between living things. At this time, the ocean is heavy with dissolved minerals and organic fragments, shaped partly by lightning, partly by sunlight, and partly by the geological restlessness of the world itself. The waters are warm, stirred constantly, and full of possibility. But nothing here is trying to speak. No molecule has a purpose beyond simply existing and reacting when pushed by chance. If communication is a language, then early Earth is still learning its alphabet, one accidental arrangement at a time. In these primordial pools, molecules float freely, not in straight lines or graceful arcs, but in jittery fits propelled by heat. One moment they drift together, the next they bounce apart, as if startled by their own enthusiasm. Every collision is an experiment written in the tiniest of scripts. Will they bind, break, share electrons, absorb energy, or transform entirely? These chemical interactions are not messages. They aren't meant for anyone. And yet, they set the rules that future forms of communication will someday rely on. Like the foundations of a house, they must be placed long before walls and windows can exist. As the planet cools and stabilizes, certain molecules begin to form more readily than others. Chains of carbon grow longer and more ambitious, folding into shapes that change the way they interact with the world around them. Some cling to each other with stubborn loyalty. Others fall apart at the slightest insult. Among them are the first protobiological structures, lipids that assemble into tiny bubbles, and nucleic acid precursors that carry fragments of information, though they cannot yet use them. They are not alive, not truly, but the universe is nudging them in that direction. In this early chemistry, there is no intention and certainly no strategy, but there is something that resembles the faintest echo of communication: reactivity. When one molecule changes shape in the presence of another, it is responding, not consciously, but mechanically. When energy flows through a system and forces its components to rearrange themselves, the system is recognizing and adapting. It is not communication, but it is the seed of communication, the way a distant vibration echoes long before a voice arrives. Imagine two molecules drifting close after hours of wandering the warm currents. One has a particular structure that causes it to grab onto the other. Suddenly, the pair stabilizes in a new configuration, and nearby molecules react differently in response. Not because they witnessed anything, of course, but because their surroundings have been subtly transformed. One tiny change ripples outward, affecting countless tiny neighbors. It is the world's first demonstration of cause and effect, unintentional, but undeniably influential. If evolution had a to-do list, this would be item 1. Build something that notices what happens around it. Slowly, conditions allow greater complexity to accumulate. Chemical gradients form, areas richer in one substance than another, and molecules drift along these invisible slopes like leaves on a gentle breeze. And though they do not know it, they are following the earliest form of a signal, a pattern in their environment that guides their movement. In time, these gradients will become rivers of information for newly forming life, but for now, they simply coax matter into motion. All of this unfolds without the slightest hint of awareness. There are no organisms, no instincts, no desires. Yet, the groundwork for every future conversation, every chirp, scent, color flash, or whispered call, is being assembled piece by piece. Evolution, still silent, is practicing its first breaths. It experiments endlessly, mostly by accident, occasionally by luck. And in doing so, it tests the physics that will eventually govern how life communicates, how signals travel, how structures hold, how energy flows, how systems respond. The ocean, unaware of its own potential, continues to swirl. Sunlight warms its surface, deep water cools its floor, and minerals seep in from the crust. The world below is a chemical library waiting for its first reader. These interactions, simple, small, and entirely unintentional, become the scaffolding for life's earliest forms of interaction. For communication to exist later, there must first be boundaries, reactions, and feedback. A living cell will someday sense the presence of another cell and respond. But that ability begins here, with molecules that change simply because physics insists they must. And so, in this quiet era before life, before voices, before signals, something profound is already underway. Chemistry is becoming organized. Reactions are becoming predictable. Systems are becoming stable enough to hold information, even if they cannot yet pass it along. The world is not speaking, but it is listening to itself in the only way it knows. Through the shuffle of atoms, the rise and fall of energy, the gentle suggestion of structure. This is where communication begins, not with a sound, but with a response. And although evolution hasn't started talking yet, it is indeed clearing its throat, preparing for the long and winding story ahead. Early life discovers chemistry as language. Cells release molecules into the water, unintentionally signaling presence, danger, or opportunity. These are not words, just biochemical side effects that others learn to interpret. Soft humor. No one meant to send a message. Everyone just learned to read the leaks. In the gentle dimness of Earth's ancient oceans, long after chemistry first learned to arrange itself into self-maintaining forms, something new begins to emerge, not by intention, but by the simple consequences of being alive. Here, drifting through the mineral-rich shallows and deeper basins, are the world's first true cells. They are small, delicate, and utterly unaware of the significance of their existence. And yet, they are about to start something remarkable. The earliest conversations in the history of life. Each of these single-celled pioneers lives inside a thin membrane that protects it from the restless water around it. That membrane is a gateway for exchange. Nutrients flow in, waste flows out. And in that continuous trade with the environment, a subtle opportunity arises. What leaks out of one cell becomes part of the surrounding world. And because nearby cells are also immersed in this shared water, they experience the consequences. It is not communication in any deliberate sense, but it is an interaction shaped by life itself, which in time will be enough to change everything. When a cell breaks down nutrients, it releases molecular fragments into the water. When it grows, it emits certain byproducts. When it struggles, its internal chemistry shifts, and the surrounding water shifts with it. Every metabolic flicker sends molecules drifting outward, creating tiny, temporary clouds of chemical influence. Another cell, floating into one of these unseen plumes, might react. It might slow down, speed up, move closer, or drift away. Not because it understands anything, but because its own chemistry has evolved to respond to these subtle cues. These responses are simple, primitive reflexes engraved in molecular pathways, but they provide the earliest hints of preference, avoidance, and detection. In a world where everything is microscopic and blind, chemistry is the only voice, and the ocean is the only medium through which that voice can travel. If the water could speak, it would say that it is becoming richer, more expressive, more full of signals that no one meant to send, and yet everyone is beginning to heed. One of the earliest forms of these chemical whispers involves attraction. Certain cells grow more efficiently when they happen to drift close to others of their kind. This is not sociality, it is survival through proximity. When a productive cell releases beneficial byproducts, nearby cells sense those molecules and move closer, as if drawn by an invisible current. They aren't forming communities yet, but they are discovering that the world feels slightly more favorable in the company of neighbors. Over time, natural selection encourages cells that respond to these beneficial cues. The ocean, once a place where every cell wandered alone, gradually becomes dotted with loose gatherings. Not structured colonies, not yet, but clusters born from shared chemistry. There are also molecules that signal danger, though again, not intentionally. When a cell's membrane is damaged by harsh temperature shifts, turbulence, or predatory molecules, it releases internal components into the water. These abrupt bursts of unusual chemicals drift outward, and nearby cells, shaped by generations of survival, learn to recoil. Moving away from damaged neighbors increases the likelihood of avoiding whatever caused the harm. Thus, even without awareness, early life develops a crude sense of warning, an unspoken, accidental alert system carried by the tides. Other chemical whispers emerge from competition. When resources are scarce, some cells release substances that make it harder for others to thrive. These molecules inhibit the growth of competitors, not because the cells know they are doing it, but because those that produce these substances tend to survive slightly better. In a sense, the earliest chemical conflict arises, not through aggression, but through the simple chemistry of advantage. And though it is quiet and invisible, this chemical friction shapes evolutionary paths with surprising decisiveness. Among the most elegant of these new signals are the molecules that reflect internal population levels. As certain types of cells multiply, the concentration of their metabolic byproducts grows. Before long, the density of these chemicals becomes an indirect measure of how many others are nearby. When populations are low, cells behave one way. When populations rise, their internal chemistry shifts, often triggering collective changes, like producing more surface proteins or adjusting metabolic speed. No one agreed on this system. No one invented it. But it becomes a shared language nonetheless. A statistical conversation conducted entirely through drifting molecules. Within this microscopic world, each cell is fragile, but together they sculpt a landscape of information. The ocean is no longer a blank environment. It is becoming a tapestry of gradients, trails, and plumes, each carrying hints about life's presence. If one could shrink down and watch, it would look like a shimmering galaxy of invisible signals, cells leaving chemical footprints in the water, others following or avoiding them, each action prompting the next. It is a conversation without meaning, yet full of consequence. And there is a curious beauty in its unintentionality. These early organisms do not know they are communicating. They do not broadcast or listen with any awareness. They simply exist, and in existing, they influence. They leak, and others read the leaks. This is the first primitive vocabulary of life, a vocabulary written by necessity, refined by chance, and understood not through insight, but through survival. Every later innovation in communication, from bright feathers to whispered calls, rests on this original chemical foundation. In this chapter of Earth's story, communication is not yet a tool or a strategy. It is merely a natural result of being alive in shared water. But even in its simplicity, it contains the seed of every message that evolution will one day craft. The first conversations are quiet, accidental, and entirely chemical. And though no one intends to say anything, the ocean is beginning to feel just a little less alone. Quorum sensing evolves. Cells begin to count each other chemically, altering behavior when numbers rise. Communication now changes group behavior. Biofilms form, defenses activate. Listening becomes as important as speaking. Gentle humor. Even microbes prefer not to act alone unless the room feels full. In the vast, ancient oceans where life first blossomed, single cells soon discovered a truth that would echo through all future evolution. Sometimes, being alone is not the most efficient way to survive. The early Earth offered plenty of challenges: fluctuating temperatures, unpredictable currents, scarce nutrients, and an environment that occasionally shifted its chemical temperament without warning. In such a restless world, a lone cell could do only so much. But if many cells gathered and behaved in concert, the ocean responded differently. It bent just slightly toward cooperation. This chapter unfolds at the moment when microbial life begins to sense not just the environment, but one another. The water is still filled with drifting cells, each following its own metabolism, but something new stirs in the chemical haze. Certain molecules, released as part of everyday cellular activity, accumulate when many cells are near. And unlike the subtle, accidental cues of earlier eras, these molecules begin to change how cells behave. They become environmental tallies, chemical head counts whispering in their own way how many neighbors are present. This process, quorum sensing, emerges quietly but profoundly. A single cell, floating alone, produces signaling molecules that simply diffuse into water and disappear. But when many cells populate the same patch of ocean, their collective emissions rise. The local concentration increases, forming a gradient that acts like a biological census. Suddenly, a cell doesn't just exist in isolation. It has a sense, however crude, of community size. At first, this sensing is accidental, a byproduct of simple chemistry. But over generations, natural selection shapes cells that respond to these signals. Those that alter their behavior when surrounded by many others survive certain conditions more successfully. This responsiveness becomes a microscopic wisdom. If there are many of us, then perhaps we should act differently than when there are few. And so behaviors begin to shift. A sparse neighborhood of cells behaves in quiet, resource-saving ways. They drift, feed, and divide slowly, as though wary of exhausting the limited molecules around them. But once the chemical concentration crosses a threshold, once the room feels full, everything changes. Genes switch on, enzymes surge into activity, and the collective flips into a new mode. It is as if the cells, without ever exchanging a word, agree that now is the time for action. One of the earliest and most significant of these communal actions is biofilm formation. When enough microbes gather, they begin secreting sticky substances, long tangled polymers that anchor them to surfaces, rocks, sediments, vents, or even each other. What starts as a cluster becomes a sheet. What begins as a sheet becomes a layered structure. The ocean floor slowly acquires patches of living fabric, soft to the touch and resilient to disturbance. These biofilms change everything about how microbial life experiences the world. The water may swirl above them, but inside the biofilm, conditions are calmer, nutrients concentrate, and the community becomes more protected from sudden chemical shocks. This cooperative architecture is not built by any leader. No microbe sketches the blueprint. Instead, quorum sensing triggers each individual to contribute its small piece once the population reaches a certain density. In this way, early communities become capable of modifying their environment, an ability that will eventually lead to reefs, forests, and complex ecological engineering. But here, in these first communal structures, the logic is simple: strength in numbers, structure in unity. Quorum sensing also shapes microbial defense strategies. A single cell cannot produce enough protective enzymes or toxins to deter would-be threats. Its efforts drift away before accomplishing much. But when a dense community reacts together, when the chemical tally signals danger or crowding, the response becomes powerful. Many cells, producing the same defensive compounds at the same moment, create a concentrated chemical cloud that repels competitors or neutralizes harmful substances. Alone, a cell is vulnerable. Together, they become a coordinated chemical orchestra. And in this new world of microbial crowd sensing, listening becomes just as important as producing signals. A cell that cannot interpret the rising concentration of quorum molecules behaves inappropriately. It exerts energy when it should be conserving it, or stays quiet when it should be participating in collective action. Over time, listeners thrive. Cells begin to refine receptors that fit perfectly with the molecules their peers emit. These receptors act as microscopic ears, tuned not to sound but to the faint, ever-shifting chemistry of the water. Gradually, a kind of microbial etiquette forms, enforced not by intention, but by evolution. Cells behave individually when they are few, collectively when they are many. This duality grants them flexibility. It is the earliest form of conditional behavior in Earth's history, a precursor to all future systems where animals, fungi, and even plants adjust their actions based on social context. If one could watch this world up close, it would resemble a living mosaic of chemical communication. Clouds of signaling molecules drifting, communities thickening, cells diving into group action, then dispersing when conditions shift. The ocean floor becomes a patchwork of tiny civilizations, each governed by a kind of emergent democracy, where the majority decides, chemically, what happens next. What makes this moment remarkable is not only the cooperation, but the fact that it arises from simple rules. There is no consciousness, no deliberation. Yet evolution has given cells a way to gauge the presence of others and modify their behavior accordingly. The result is the first instance in which the survival of an individual depends on understanding its social environment, even if that understanding is purely molecular. And so, without ever meaning to, microbes become the world's first community builders, first environmental engineers, and first practitioners of collective behavior. They gather when the room feels full, retreat when it empties, and change their world not through strength, but through numbers. For life, this is a turning point. Communication has evolved beyond mere response. It is now a tool that shapes group destiny. And in this simple act of sensing the crowd, evolution discovers that survival is often a shared experience, especially when everyone knows how to listen. With bodies come movement, and with movement, signals. Shape, texture, and posture begin to convey information. Brightness warns, bulk intimidates, stillness conceals. Communication becomes visible, even if eyes are still simple. Soft humor, sometimes saying nothing, very dramatically, works best. The moment life acquires bodies, true bodies, composed of many cooperating cells, is the moment the world gains its first physical gestures. After ages of drifting chemicals and invisible cues, evolution suddenly has a new canvas to work upon: form itself. Early multicellular organisms do not yet boast the architectural variety of the modern world. No fins, no legs, no feathers, but they have something unprecedented. They have shape, they have presence. And even though they do not move with intention or emotion, the simple fact of their bodies enables them to send messages through posture, contour, and the ways they interact with light and water. Imagine the ancient seas at this stage: wide plains of soft sediment, forests of simple fronds waving with the tides, and clusters of flattened, quilt-like creatures resting on the seafloor. These organisms are quiet, slow, and entirely unaware of interpretation. Yet everything about them can be interpreted. The slant of a surface, the spread of a frond, the height of a protrusion. All these features influence how other organisms perceive them. Communication here is not invented. It is discovered by accident, expressed through physics, and noticed through survival. One of the earliest gestures life learns is stillness. In a crowded, shifting sea, most organisms move with the rhythm of the currents. Remaining motionless, flexing no tissues, drifting nowhere, creates a kind of invisibility. Soft-bodied predators of this era do not yet hunt with vision, but they sense vibrations and pressure changes. A creature that goes completely still leaves only the faintest signature in the water, and this becomes a silent way of saying, "I am not here." It is a message of absence spoken through the body, and it works remarkably well. Stillness is the first physical strategy of concealment, a precursor to every camouflaged animal that will one day freeze against bark or sand. And though these early creatures do not plan it, evolution is quick to favor bodies wired for calm composure. Another gesture arrives through expansion. Some organisms develop the ability to slightly swell their tissues when disturbed, increasing their apparent size. This response is not deliberate. It is the result of fluid shifts within the body triggered by touch or pressure. But an organism that appears larger becomes slightly harder to swallow, and so predators often seek easier meals. Over time, those who puff up even a little survive better, and a simple communication emerges. I am larger than you think. It is a bluff created by anatomy, but a bluff that works. Bulk becomes a statement, silent but effective. Brightness, too, enters the evolutionary dialogue. In these early eras, light is a precious resource. Many organisms settle where sunlight filters through the water in soft, wavering beams. Some absorb this light, some reflect it, and some scatter it through translucent tissues. Variation in brightness becomes information. A body that shimmers faintly in the currents often signals pliability, easy to tear, worth chasing. A body that gleams brightly with mineral deposits or dense collagen conveys toughness, and predators learn through trial and error that such meals are exhausting to chew. Thus, brightness becomes a quiet announcement. Approach if you're prepared for the effort. Texture offers even more possibilities. Some early animals develop surfaces covered in tiny ridges or bumps. These structures, born from random mutations affecting cell arrangement, create micro-patterns that alter how water flows around them. Predators brushing past them in the dark feel this unexpected roughness and sometimes recoil, unfamiliar with the sensation. The tactile world becomes a landscape of messages, each felt rather than seen. Smoothness whispers vulnerability. Coarseness suggests resilience. Without a single conscious signal, the physical world becomes a coded system of implied intent. As bodies become more varied, movement takes on communicative power. A slow, rolling sway advertises softness and docility, traits that predators quickly learn to exploit. A sudden contraction or ripple of muscle, on the other hand, sends a clear signal through the water. Something alive and responsive is present, something not to be taken lightly. Early multicellular organisms do not flee with any sophistication, but the way they recoil or fold their tissues creates a kind of visual or tactile emphasis. These reactions are survival tools, but they also carry meaning for others. I notice you, I can resist, or I prefer you not to come closer. Even posture begins to matter. Some organisms rise slightly higher from the seafloor, supported by stiffened internal structures. Their elevated stance allows them to intercept drifting nutrients, but it also makes them appear more imposing. Others remain pressed against the substrate, signaling a different lifestyle, sheltered, unobtrusive, and therefore not worth the attention of passing grazers. In a world without eyes capable of appreciating detail, silhouette becomes everything. A body's outline is its entire vocabulary. And yet, the most important aspect of this new physical communication is not what the organisms broadcast, but how others learn to interpret. Early sensory receptors, nestled along the surfaces of simple creatures, become more sensitive to pressure, texture, and chemical traces of touch. These receptors allow organisms to distinguish shapes and movements with surprising accuracy, even in darkness. It is here that communication becomes relational. A gesture has meaning only because another organism reacts to it. Evolution shapes both sides simultaneously, the signaler and the perceiver, creating a delicate feedback loop that will eventually give rise to displays, dances, warning patterns, and all the expressive repertoire of later life. Through all this, the ocean itself becomes a stage for physical expression. Every sway of a frond, every shimmer of a surface, every strategic stillness becomes part of the emerging lexicon of multicellular life. And while none of these creatures knows they are sending messages, their bodies speak in ways that shape survival. A gesture, deliberate or not, becomes a form of information, one that evolution will spend millions of years refining. In these quiet waters, before eyes sharpen and before complex behaviors emerge, communication begins with posture, movement, and presence. And sometimes, saying nothing, very dramatically, with perfect stillness, speaks the loudest of all. Eyes sharpen the evolutionary dialogue. Color, pattern, and motion become tools. Now signals can deceive, seduce, or terrify from a distance. Communication accelerates arms races between signalers and interpreters. Gentle humor. Evolution discovers that looking impressive saves a lot of running. As the Cambrian seas awaken, light becomes more than a gentle shimmer across the water. It becomes information. For the first time, organisms develop structures sensitive enough to detect brightness and darkness, direction and movement, and eventually shapes and colors. Vision emerges not as a single invention, but as a series of escalating improvements, each granting its bearer a clearer window into the world. This clarity transforms survival. It transforms strategy. And most importantly for our story, it transforms communication into something visible, deliberate, and dramatically expressive. Before eyes, the ocean was a place of touch and chemistry. Signals drifted slowly, carried by water's patience. But vision changes the pace of interaction. Now messages can leap across distance in the blink of a new, astonishing organ. A creature no longer needs to be brushed or bumped or chemically sampled to be noticed. It can be seen. And being seen opens an evolutionary floodgate for communication through patterns, movements, and displays. The earliest eyes are simple, little more than patches of light-sensitive cells. They cannot form images, but they can detect differences. Light above, dark below, a sudden shadow drifting past. Even this modest awareness alters behavior. Organisms begin to orient themselves in the water column, adjusting position based on brightness. They learn, without knowing it, that light offers safety from certain predators and no safety at all from others. This simple reading of the environment marks the beginning of visual interaction. But evolution, as always, is restless. Light-sensitive patches gradually deepen into cups, then narrow into pits, then cover themselves with transparent layers. Each shift sharpens resolution. Each improvement grants more information. And as eyes improve, bodies begin to adapt around them, embracing new opportunities for communication through appearance. Color enters the evolutionary palette through pigments, molecules that absorb some wavelengths and scatter others. At first, pigments protect tissues from intense sunlight or serve as byproducts of metabolism. But in a world where eyes notice contrast, pigments also become declarations. A bright patch warns of toxins. A pale streak confuses predators by breaking up outlines. A shimmering stripe catches attention, whether for attraction or intimidation. Suddenly, the ocean hosts more than just life. It hosts spectacle. Patterns quickly follow. As tissues fold and proteins arrange themselves in complex ways, repeating motifs appear. Stripes, bands, spots, chevrons. Some patterns start as camouflage, blending organisms into seafloor mud or shadowed reefs. Others stand out boldly, advertising strength or distastefulness. A creature with a vivid pattern sends a message across meters of open water. I may not be worth the effort, long before any predator comes close enough to investigate. Evolution, noticing the advantage, obliges by polishing these patterns into clearer and more emphatic signals. Motion, too, becomes communication. A sudden flick or undulating ripple now carries meaning visible from afar. When a predator sweeps past, a tiny creature's darting escape trajectory can confuse the attacker, making pursuit less likely. When a competitor approaches, a raised fin or rhythmic sway may serve as a territorial warning. These actions are not conscious signals, but evolution begins to favor movements that transmit information effectively. Quick displays to intimidate, slow glides to appear confident, erratic jittering to deter pursuit. The entire ocean becomes a stage of kinetic messages, written in the language of movement and light. Perhaps the most transformative outcome of these new visual interactions is deception. Once organisms can be seen, they quickly learn, through the long arithmetic of natural selection, how to mislead one another. Some develop eye-like patterns on their backs, startling predators who mistake them for something dangerous. Others evolve shimmering surfaces that scatter light into confusing distortions, hiding their true shape beneath shifting reflections. A few adopt false shapes entirely, imitating plants or stones. These illusions are not intentional tricks. They are traits that succeed simply because others interpret them incorrectly. And in a world where eyes are evolving rapidly, interpretation changes constantly, driving a visual arms race that defines the Cambrian explosion. Predators gain sharper eyes, able to detect finer details and faster movements. Prey develop more intricate patterns, more strategic gestures, more elaborate forms of camouflage. The result is an accelerating cycle that fuels complexity across the board. Communication becomes two-sided, dynamic, and reactive. No longer is it enough to simply display. One must display better. A creature that looks intimidating becomes safer. One that blends into the background survives longer. One that dazzles or distracts may earn a crucial advantage. Evolution begins to sculpt beauty not for beauty's sake, but because every shade, line, and flicker carries meaning. And in this era of escalation, certain bodies become masterpieces of visual expression. Spined animals fan their armor into imposing shapes when threatened. Soft-bodied swimmers flash iridescent waves across their surfaces. Burrowers reveal only a portion of themselves, offering the slightest peek to mislead or seduce. Even creatures with crude, primitive eyes begin to recognize these signals, responding instinctively. A curled posture suggests danger. A gaping maw hints at toxins. A boldly contrasting pattern warns, "I am armed, and you will regret testing this." Vision does not merely enhance communication, it amplifies it. Messages that once drifted slowly now travel instantly. Signals that once acted on contact now operate at a distance. Every species becomes both broadcaster and interpreter, whether it wishes to or not. The ocean fills with light, shadow, color, silhouette, and motion, elements that together form an early vocabulary of visual meaning. In this brilliant, teeming world, evolution learns something important: that looking impressive saves a remarkable amount of energy. A bold display can turn conflict into avoidance. A clever pattern can transform vulnerability into invisibility. And a dramatic gesture, executed at just the right moment, can resolve a dispute before it even begins. Thus, as the Cambrian seas shimmer with new eyes and new forms, communication takes a leap forward. Bodies become billboards, performances unfold in every current, and life begins to express itself in ways that reshape the future of every species to come. Before voices, there are vibrations. Water carries pressure changes well, and bodies learn to feel them. Communication becomes rhythmic. Bumps, pulses, low-frequency thumps felt more than heard. Soft humor. It's not talking yet, more like politely knocking on existence. Long before the world heard its first true call or underwater song, the oceans pulsed with a quieter, more ancient form of communication: vibrations. In these early seas, sound as we now know it is still in its infancy, not yet sculpted by vocal cords or airy resonances. Instead, life learns to speak through pressure changes, tremors, and the subtle movements that ripple outward through water's dense, receptive body. These messages are not broadcasted with intention, yet they travel reliably, carrying cues that shape the survival of the creatures who feel them. Water, as it happens, is a superb medium for vibrations. More than any gas, it transmits disturbances swiftly and with little loss. A single flick of a fin, a shift of a muscle, a thump against the seafloor, all send tremors outward in widening rings. Early aquatic animals, lacking sophisticated eyes or chemical senses sharp enough for distance, begin to lean on this tactile information. Vibrations become their early warnings, their social indicators and their subtle announcements of presence. In the dim, grainy light of the seafloor where primitive animals explore, these vibrations act like whispers. A grazing creature nudging sediment with its body produces a soft tremble that lets others gauge how close it is. A sudden darting motion sends sharper pulses, signaling alarm or abrupt movement. These early tremors are not coordinated signals, but evolution quickly recognizes their value. Organisms that can detect and interpret these pressure waves survive more often than those who remain oblivious. This sensitivity emerges through specialized cells embedded in soft tissues, cells that bend or deform in response to the slightest pressure change. These mechanoreceptors are the ancestors of lateral lines in fish, the first tools that turn physical disturbances into interpretable information. At first, these receptors simply alert creatures to collisions or nearby movement. But soon, they begin distinguishing patterns, learning to recognize the difference between the gentle sway of water stirred by harmless neighbors and the abrupt, staccato pulses created by a predator's approach. As animals grow more complex, so do the vibrations they produce. Some begin to pulse purposely, not to communicate in any deliberate sense, but because their bodies, reacting to threats or internal rhythms, emit consistent patterns. When disturbed, many early animals reflexively contract, sending a single strong ripple. Others flick their appendages in repetitive bursts when foraging. These patterns become recognizable cues in the underwater world, a rhythmic beat that says, "Something is alive here," long before sight or scent confirms it. Over time, certain creatures adopt vibration not just as a consequence of living, but as part of their survival strategy. Some burrowing animals develop muscular structures that allow them to thump the ground rhythmically. These thumps help them navigate soft sediment, each vibration reflecting differently depending on what lies beneath. But these pulses also have unintended social uses. Nearby creatures feel the tremors and adjust their behavior accordingly. An organism sensing rhythmic thumps might move away to avoid competition or move closer to investigate potential opportunity. As always, communication evolves not through intention, but through the benefits of being understood. Other organisms take advantage of the ocean's acoustic sensitivity by altering their locomotion. A slow, steady undulation produces a gentle, flowing signal associated with calmness. A sudden lurch triggers a sharp vibration, instantly interpreted as danger. Even without meaning to, creatures begin to broadcast emotional states through their movement patterns. Prey species, learning from experience, freeze when the water suddenly shivers with predator-like pulses. Predators, in turn, refine their movements to minimize the vibrations they create, adopting slower, stealthier approaches that carry less warning across the water. In some shallow environments, especially along ancient reefs and mound-like structures, groups of animals live in tight proximity. Here, vibrations serve as early forms of coordination. When one animal shifts abruptly, the tremor spreads through the substrate or water, alerting neighbors and prompting communal responses, scatterings, retreats, or synchronized stillness. These waves of collective motion resemble choreographed dances, though no one involved is aware of the performance. It is simply that moving together in response to shared signals keeps everyone alive more effectively. With increasing complexity in nervous systems, creatures begin to discriminate more finely. They sense not only the presence of vibrations, but also their texture, the deep, resonant pulse of something large dragging along the seafloor, the fluttering, erratic tremor of a small creature feeding, the steady rhythm of a distant crawler. This emerging ability turns vibration detection into a rudimentary language of categories: predator, prey, neighbor, stranger, each embodied in the shape of water's trembling. Some species evolve appendages designed to amplify their own signals. Fringed limbs, ridged plates, or broad fins create distinct vibrational signatures when moved. These structures might have originally served locomotion or stability, but evolution co-opts them for signal production. When a creature sweeps its fin just so, it sends a clear, deliberate pulse that ripples farther and with more clarity than a simple body twitch ever could. Over millions of years, certain lineages refine these movements into repeated patterns, proto-rhythms that help individuals maintain spacing or signal their presence when searching for mates or feeding grounds. Other animals use the surrounding landscape as an instrument. By tapping, rubbing, or dragging their bodies across hollow structures, ancient sponges, shell-like formations, or porous rocks, they generate vibrations that resonate more loudly. These resonances can attract or warn off others depending on context. Though unintentionally crafted, these behaviors mark the earliest emergence of animals shaping sound through interaction with their environment. In this watery realm, vibration becomes the first true medium of distance communication. It is limited, yes, blurred by currents, distorted by obstacles, but it works. It works before lungs, before vocal folds, before any creature learns to consciously produce a sound. And in its own humble way, it paves the path for later acoustic marvels. The songs of whales, the clicks of dolphins, the drumming of fish. For now, however, the ocean speaks in low pulses, gentle knocks, and soft tremors. Not quite conversation, not quite signal, but something in between. A delicate acknowledgement that life is present, moving, and aware. It's not talking, yet more like politely knocking on existence and waiting to see who or what knocks back. Air transforms sound into a powerful messenger. Croaks, hisses, and chirps emerge, shaped by lungs, throats, and environment. Communication can now travel around corners and through darkness. Gentle humor. Finally, evolution finds a way to complain loudly about the weather. When life first edges onto land, the world is a patchwork of new challenges: dryness, temperature swings, and a sky that stretches spacious and silent above the crawling pioneers. But in this silence lies possibility. Sound, which underwater was a muffled and pulsed phenomenon, behaves differently here. Air gives it freedom. Air gives it shape. Air gives it resonance. And the creatures adapting to this vast new medium soon discover that noise, true airborne noise, can become one of the most versatile tools in their evolutionary toolkit. The earliest land dwellers are not sophisticated vocalists. Their ancestors were accustomed to the dense push of underwater vibrations. Here, in the thinness of the atmosphere, movement feels strangely muted, but they carry within them an innovation that will change everything: air-driven respiration. Lungs, originally evolved to solve the problem of oxygen intake in shallow, low-oxygen waters, suddenly find themselves perfectly suited for the task of creating sound. All they need is a bit of anatomical creativity, some folds here, some chambers there, and the breath that once simply fueled life will begin shaping it in new ways. The first noises are crude: snorts of escaping air, accidental rumbles from contracting muscles, squeaks made when damp skin catches against itself. None of these are purposeful, but the environment notices. Air carries these sounds farther than water would have. A startled exhale can reach an animal hidden behind a rock. A throat's involuntary flutter can alert neighbors of presence or agitation. Even a clumsy rasp becomes a message when it echoes more loudly than expected. As land animals adapt, many develop soft tissues inside their throats that vibrate when air is forced past them. These tissues, sometimes simple membranes, sometimes complex folds, become the ancestors of vocal cords. The first true terrestrial sounds emerge: low croaks produced by expanding air sacs, sharp hisses produced by squeezing breath through narrow passages, rhythmic chirps created when two stiffened structures tap or rub together. Each sound is shaped by the size, shape, and elasticity of the animal producing it, creating a diverse acoustic landscape. These early calls are not planned speeches, of course. They are reflexes molded by survival pressures. When a predator rustles through leaf litter, a small creature may release a sudden hiss, not because it decides to warn or intimidate, but because internal muscles tense and force air through its throat. Some predators, startled by the noise, hesitate just long enough to give the little creature a chance to flee. Over generations, natural selection encourages those whose accidental noises startle more effectively. Thus, defensive hisses evolve into genuine warning calls. As communication becomes more consistent, sound reveals its tremendous advantages. Unlike chemical signals, which drift slowly and fade gradually, airborne sound is immediate. It races outward in expanding waves, cutting through foliage and bending around obstacles. A distress call can be heard by individuals hidden beneath ferns or perched on stones, long before they see the threat. And unlike visual signals, sound works even in the deepening dusk, when shapes blur and shadows lengthen. In this dim half-light of early terrestrial evenings, the acoustic world becomes alive. Small creatures seeking mates use sound to reach across darkness. A low croak from one patch of moist ground invites a response from another. The rhythms become recognizable, then distinctive. Sound grows into an identifying feature, allowing individuals to distinguish potential partners or competitors simply by tone and cadence. Some animals develop inflatable throat sacs that act like resonating chambers, amplifying their voices beyond what their small bodies could produce alone. Each inflation and collapse creates a dramatic bobbing motion, unintended theatrics that, incidentally, help potential partners locate the source. Others evolve specialized surfaces that vibrate rapidly when struck by airflow, generating high-pitched chirps that carry surprisingly far in the stillness of night. These innovations turn the land into a dome of overlapping voices, each bouncing in its own direction, each carrying its own purpose. Among these vocal pioneers, certain species begin to use sound to maintain territories. A resonant call broadcast at deliberate intervals declares that a patch of earth, moss, or shallow water has a current occupant, and one who prefers solitude. Competitors who hear the call often reconsider their approach, choosing a quieter route. This is not diplomacy in any conscious form, but it serves the same purpose. Conflict is reduced through the efficient distribution of information. Sound becomes a tool of negotiation. Even predators find ways to exploit this new medium. Some learn to recognize the specific distress calls of potential prey, using these signals like accidental lighthouses, guiding them toward concealed animals. Others use soft, rhythmic noises to coordinate group movements or synchronize ambushes. In this way, sound shapes both sides of the predator-prey arms race, sharpening awareness and prompting ever more refined listening abilities. Listening itself becomes crucial. As ears develop, initially as simple vibration detectors repurposed for air, animals begin to discriminate the direction, intensity, and frequency. They can tell whether a sound originates from above or below, near or far. They learn, through countless generations, to distinguish ambient noises of wind and leaves from the meaningful thrum of living creatures. With each refinement in hearing, communication grows more nuanced. As vocal diversity blossoms, so does its expressive range. Some sounds soothe, soft purr-like hums used by early parental species to calm offspring. Others warn, sharp clicks or snaps produced when creatures flex rigid structures in their throats. A few evolve rhythmic sequences, early proto-songs, used in courtship rituals. Each sound, whether harsh or melodic, carries meaning shaped entirely by survival. And amid this rising chorus, one truth becomes clear. Evolution has finally discovered a way to vocalize its many grievances. A creature may not know it is using sound to express irritation, but when the sun dries a once comfortable patch of mud and a grunt echoes through the reeds, it is hard not to imagine the sentiment. Really? Today of all days? With sound liberated into air, communication transforms yet again. Messages no longer rely solely on proximity or line of sight. They travel freely through space, shaping relationships, guiding behaviors, and weaving early societies from otherwise solitary creatures. In these first voices, rough, simple, and earnest, we hear the beginning of something vast, a world where life speaks, listens, and begins to fill the land with its own resonant story. Repetition enters communication. Rhythms signal identity, readiness, and fitness. Timing becomes information. Night fills with layered soundscapes, each species carving out its own acoustic space. Soft humor. Everyone sings, but no one wants to share the microphone. As Earth's early landscapes settle into their long cycles of dusk and dawn, a new kind of communication begins to rise. One woven not just from sound itself, but from the pattern of sound. The world has already learned to speak in hisses and croaks, but now it begins to speak in beats, pulses, trills, and measured repetitions. Rhythm steps onto the evolutionary stage, and with it comes an astonishing leap in the sophistication of communication. This transformation begins with the arrival of creatures whose bodies and lifestyles demand precision. Amphibians, with their dual existence on land and in water, discover that timing can compensate for their limited visibility at night. Insects, newly flourishing with their jointed limbs and experimental wings, stumble upon the acoustic potential of rubbing, tapping, or vibrating their body parts. Early reptiles, sturdier and more deliberate, add their own contributions. Low grunts and patterns that reflect position, territory, or mood. The world grows noisy, but not chaotically so. Instead, nature begins layering its sounds like an orchestra tuning itself by accident. One species clicks slowly, another chirps rapidly, another croaks with 2 beats and a pause. Each finds a tempo that fits its physiology and its place in the acoustic landscape. These differences, at first incidental, soon become essential. If you cannot outshout your neighbor, you can at least out-timing them. In the earliest of these rhythmic communicators, repetition arises because it works. A single call may go unheard, muffled by foliage or lost in the dense textures of nighttime. But several calls, spaced evenly, form a pattern that ears and primitive brains latch onto more effectively. Repetition also conveys more reliable information. A creature that can sustain a rhythmic signal demonstrates stamina, health, and stability. A weak or inconsistent rhythm hints at illness, youth, or inexperience. All crucial data for listeners trying to make decisions about mates, rivals, or threats. Amphibians are among the first to turn rhythm into a nightly declaration of presence. Males gather near still waters where their eggs will one day rest. And from these damp stages, they begin calling in pulses. Not just once, but again and again, forming motifs that echo across the surface like small ripples of sound. Their rhythms differ by species. Some call in clusters of 3, others in long, drawn-out notes, and still others in bright staccato bursts. Each pattern is a signature, a way of announcing identity without having to reveal oneself physically. For creatures vulnerable to predators, this is a blessing. Insects, meanwhile, explore an entirely different sonic toolkit. Lacking lungs and vocal cords, they rely on mechanical ingenuity. Wings vibrate, legs scrape, exoskeletons resonate. A nighttime meadow becomes a laboratory of rhythmic invention. Katydids, crickets, and early cicada-like ancestors generate beats that are astonishingly precise. 2 individuals may chirp at very similar frequencies, yet each introduces slight variations in timing. Tiny rhythmic fingerprints that help potential mates distinguish one singer from another. These rhythms do more than identify species. They help individuals avoid acoustic interference. When too many voices overlap, messages muddle. So evolution encourages spacing, not physical spacing, but spacing in time. Some species call at dusk, others at night's deepest silence, others in pre-dawn faintness. Even within a single habitat, individuals adjust their patterns to avoid drowning each other out. One male slows his tempo when another speeds up, like 2 drummers politely negotiating for turns. Everyone is singing, but indeed, no one wants to share the microphone. Reptiles, though not typically known as musical creatures, add their own slower, deeper rhythms. Low grunts, rhythmic tail thumps, or throat-driven pulses. They use timing to establish territories, repeating signals at regular intervals to assert occupancy. A steady beat means this ground is taken. An irregular one might be interpreted as weakness, drawing opportunistic rivals. Thus, timing becomes a form of cryptic diplomacy, settling disputes without requiring direct confrontation. As rhythm saturates these ancient soundscapes, new meanings become possible. A rapid shift in tempo can indicate alarm, A gradual slowdown might mean exhaustion or submission. A sudden silence can signal the presence of something dangerous. Entire communities begin to read these patterns instinctively, responding to the tempo of others with fine-tuned behavioral adjustments. Nightfall becomes the grand arena for rhythmic communication. Once the sun sinks, vision fades, and the weather cools, the air fills with layered sound, pulsing, clicking, croaking, chirping. To human ears, had any been present, it would resemble a complex symphony. But to the animals producing these rhythms, each beat is a thread of survival, calling mates, repelling rivals, coordinating movements, or keeping distant tabs on surrounding activity. The structure of each call subtly conveys fitness. A male amphibian whose rhythm is unwavering demonstrates respiratory strength and muscular endurance, qualities that females instinctively select for. An insect whose wing vibrations remain consistent despite wind currents shows robustness in its musculature and coordination. Repetition becomes a performance, a test, an audition for life's next generation. Listeners evolve to become connoisseurs of timing. They can detect tiny differences in intervals that separate one species from another, or one individual from its neighbor. This precision helps maintain reproductive boundaries and reduces wasted effort. It also pressures signalers to refine their rhythms further, heightening the evolutionary dance between sender and receiver. In this era, timing becomes its own form of communication, distinct from tone, pitch, or volume. Patterns become meaning. Gaps become meaning. Even silence, carefully placed, becomes meaning. And beyond all practicality, rhythm fills the ancient nights with a sense of continuity. When one call pauses, another begins. When one species sleeps, another takes the stage. Across forests, wetlands, and plains, the world seems to breathe in repeating pulses, as though all life has synchronized its heartbeat with the turning of the planet. Here, in these rhythmic exchanges, communication steps into a new dimension, organized, structured, and infinitely expressive. And as each creature finds its place in the evolving soundscape, something remarkable emerges. A world where timing is everything, and where even the smallest singer can carve out a space simply by repeating itself with confidence. Everyone sings, everyone listens, and as ever, no one wants to share the microphone. Chemical communication evolves sophistication. Scents mark territory, readiness, lineage, and memory. These messages linger, allowing communication across time, not just space. Gentle humor, some messages are meant to last, whether neighbors like it or not. Long before mammals mastered warm fur and quick reflexes, and long before insects perfected the art of miniature engineering, both groups discovered an ancient language that needed no light, no sound, and no movement. It drifted on air currents, clung to surfaces, soaked into soil, and lingered long after the sender had left. This language was scent, an invisible script written in molecules, carrying stories of identity, intent, and memory to anyone equipped to read it. Chemical communication is old, far older than these terrestrial pioneers. But in mammals and insects, it evolves into something far more intricate, more expressive, and more enduring. It becomes a medium through which lives intertwine across hours or even days. It becomes a way to leave traces of oneself on the landscape, like notes pinned to the world. And because these notes can persist, they allow messages to travel not only across distance but across time. Early mammals, small and nocturnal, find scent particularly useful. Their vision is limited, especially under the moon's thin glow, and their hearing, though keen, cannot always tell friend from stranger. But the nose offers a clarity no other sense can match. Each individual has its own smell, a complex blend shaped by diet, hormones, and microscopic secretions. It is, quite literally, a chemical biography. When a mammal brushes past a plant, its coat leaves behind tiny aromatic traces that proclaim, "I was here, and here is who I am." This accidental messaging quickly becomes intentional, honed by evolution into sophisticated scent marking. Glands positioned along the face, tail, paws, and flanks exude secretions designed to cling to surfaces. A quick rub against a stone writes a territorial boundary. A small droplet left on a pathway announces reproductive readiness. Even exhaled breath, carrying distinctive molecular signatures, helps individuals recognize one another during close, cautious encounters. These scent messages do more than declare ownership. They shape the social geography of early mammalian life. A boundary marked with a strong, confident scent tells wanderers that the land belongs to an individual who is healthy, active, and likely to defend it. A faint, fading scent suggests emptiness or weakness, silently inviting others to explore. In this way, chemical messages choreograph movements across the landscape, preventing unnecessary conflict and guiding animals toward opportunities. Insects, operating on an entirely different physiological scale, push the language of scent into unprecedented complexity. Their worlds are dense with pheromones, specialized molecules crafted for communication alone. Some pheromones trail behind foraging ants like aromatic breadcrumbs, mapping routes with exquisite precision. Others drift from queens, maintaining order within colonies by regulating the behavior and development of nestmates. Still others serve as urgent alarms, sharp, volatile signals that spread in seconds and turn scattered workers into a unified defensive force. For insects, scent is less a passive message and more a structured script, one that shapes entire societies. A single pheromone can trigger group cooperation, nest construction, or coordinated hunting. A blend of just a few molecules can transform the behavior of thousands. The air around an insect colony becomes a swirling atmosphere of coded signals, all overlapping yet distinct, guiding the collective as reliably as any spoken language ever will. What unites mammals and insects in this chapter of evolution's story is their shared mastery of communication that extends beyond the moment. Unlike visual displays, which vanish as soon as they are made, or sounds that dissipate quickly in the open air, scents linger. They fade gradually, allowing animals to reconstruct sequences of events. A fresh scent provides immediate information. Someone passed here minutes ago. A faint trace tells a different story. Someone walked this way earlier in the day. In this sense, scent becomes a form of ecological memory, mapping movements and interactions long after they occur. This lingering quality also allows animals to communicate with individuals they may never meet directly. A mammal marking a twig sends a message to future wanderers, some of whom may arrive hours or days later. An insect queen releasing pheromones during the night influences the development of larvae that hatch much later. These delayed conversations shape the structure of both solitary and social species, weaving time into the fabric of communication. The subtleties of scent grow finer as early mammals diversify. Some species develop complex scent combinations that reveal lineage, chemical signatures that indicate familial connections and help prevent inbreeding. Others produce scents that shift with emotional state. Fear, aggression, calmness, and contentment leave different chemical footprints. These nuances allow mammals to interpret context, not just identity. A fresh trail scented with stress cues warns of predators. A contented marking suggests stability and safety. Insects, meanwhile, perfect long-distance broadcasting. Certain moths, for example, evolve the ability to release pheromones that drift across astonishing ranges, carried by night breezes. Males, guided by exquisitely sensitive antennae, follow these faint chemical threads through darkness, navigating an invisible maze toward potential mates. These threads are written so lightly that predators cannot easily exploit them. Another advantage scent holds over sound or movement. But scent also has its limits. A lingering message can mislead as easily as it informs. A mammal may interpret an old boundary mark as fresh and avoid territory that is no longer defended. An insect might follow a decaying pheromone trail that ends abruptly. Yet these imperfections are part of the system. They introduce variation and keep communication dynamic, prompting animals to pair scent with other senses when necessary. Still, scent remains unmatched in durability. It is a language built to last, sometimes a little too long for the comfort of neighbors. A territorial marking on a rock may persist stubbornly, enduring rain and wind as though proud of its longevity. One could imagine evolution shrugging and saying, well, if you're going to send a message, you might as well make sure it sticks. In this era, communication becomes not only immediate and reactive, but also persistent, far-reaching, and intricately layered. The invisible language of scent turns the world into a living archive where every branch, burrow, and trail holds stories waiting to be read. Some messages vanish quickly, others linger patiently. But all of them, whether subtle or overwhelming, reshape how creatures move, meet, and make sense of one another in a world that has begun to smell richly of meaning. Expressions, coloration, and subtle movements convey emotion and intention. Communication becomes nuanced, reassurance, threat, submission, curiosity. Misreading signals now has social consequences. Soft humor. Evolution invents body language, then pretends it's obvious. When the animal world becomes social, not just coexisting, but living together, communication undergoes another quiet revolution. Sound, scent, and even rhythm still play their roles, but something new begins to shimmer through group life. The language of the body. The rise of social mammals, birds, and other communal creatures brings with it a fresh complexity. Expressions that shift in a heartbeat. Fur that fluffs or flattens with purpose. Feathers that tilt and flare. Eyes that soften or harden depending on tension. Suddenly, survival depends not just on detecting signals, but on correctly interpreting them. In these early social landscapes, individual animals no longer face the world alone. They forage together, raise young cooperatively, defend shared spaces, and navigate intricate hierarchies. And with cooperation comes conflict. With conflict, negotiation. And with negotiation, signals that must be both clear and flexible. Every twitch of a muscle or tilt of a head begins to matter. Every posture becomes a message. Faces arrive as some of evolution's most expressive canvases. Many mammals develop intricate muscles beneath the skin of their snouts, brows, and cheeks. Muscles originally shaped for eating and breathing, but now repurposed into tools of communication. A lifted lip can reveal teeth not only for biting, but for warning. A lowered head paired with wide eyes signals submission, granting safety in tense encounters. The face becomes a living gauge of internal state. Curiosity, alarm, reassurance, frustration, expectation. Even subtle changes, barely noticeable to an outsider, speak volumes within a species. Birds, lacking the soft musculature of mammalian faces, take an entirely different path. Their expressiveness unfolds through feathers. Those remarkable structures capable of forming crests, fans, and shimmering displays. A raised crest can signal alertness or irritation. A lowered one, calmness. Feathers fluffed around the neck may convey intimidation, while sleeked feathers announce relaxation or trust. Color, too, becomes an element of this vocabulary. Subtle shifts in hue or brightness indicate maturity, social rank, or the strength of a pair bond. A bird's body becomes an artist's palette, capable of delicate emotional brushstrokes. Fur mirrors this feathered artistry in mammals. The tiny muscles embedded in the skin, originally evolved for temperature regulation, also lift patches of fur into clear signals. Raised fur can make an animal appear larger, exaggerating its silhouette to discourage confrontation. Flattened fur conveys peace, respect, or deference. In some species, the movement of whiskers adds an even finer layer, tilted forward to explore, pulled back to indicate caution. Even the smallest flicker of whiskers can alter how one individual reads another's intentions. Social signals emerge not just in one part of the body, but across the whole form. A tail held high announces confidence. A tail tucked beneath the body confesses uncertainty. A slight sideways lean suggests curiosity. A rigid, forward-leaning stance spells threat. Over time, these gestures become standardized within species, codified through evolutionary pressures into recognizable patterns. Individuals who respond appropriately to such signals avoid unnecessary fights, strengthen alliances, and raise their young more successfully. Misreading these signals, however, carries consequences. In the ancient meadows and forests where these early social groups begin to roam, a friendly gesture mistaken for aggression can lead to sudden skirmishes. A dominant animal interpreting submission as defiance may react sharply. Thus, selection refines not only the signals themselves, but also the perceptual skills required to interpret them. Eyes sharpen, attention spans lengthen, and awareness of context becomes essential. Communication becomes relational, dependent on shared understanding. Even within families, signals shift in meaning. A parent bird may puff its body to encourage fledglings to stay close, while using the same gesture to warn a predator at a distance. Mammalian parents refine a repertoire of expressions: gentle nuzzles, firm head nudges, reassuring glances that guide their young through a dangerous world. These signals are subtle, tender even, and they deepen the emotional fabric of social life. As group living becomes more complex, animals begin to use entire sequences of movements to communicate. A display is no longer just one gesture, but a choreography. Approach slowly, turn the head, expose the flank, lower the posture, and emit a low sound. The meaning emerges through combination rather than individual elements. Each species develops its own grammar, its own set of social rituals, courtship dances, greeting ceremonies, conflict resolution routines. These rituals smooth interactions, transforming raw instinct into predictable behavior. Birds, in particular, craft displays that border on performance art. A slight bow followed by a feather flare might strengthen a bond between mates. A hop paired with a wing flick might test the patience of a rival. The timing, posture, and direction all matter. Social animals become masters of nuance. Meanwhile, mammals refine expressions that carry emotional weight. The soft blinking of eyes signals trust. A slow turn of the head signals invitation rather than defiance. Some species begin using facial expressions to reassure group members during stressful events, restoring calm to a flock or pack. Through these exchanges, the emotional lives of animals deepen and communication gains a new dimension. Empathy-like responsiveness, shaped by evolution to maintain social cohesion. In these early societies, the landscape itself becomes a theater of signals. A burst of fur rising across a row of small mammals alerts the group before predators are even visible. A ripple of feather tension flows through a flock moments before takeoff. Social signals allow information to spread rapidly without a single sound, a synchronized readiness achieved through shared body language. And, in typical evolutionary fashion, once body language becomes important, evolution behaves as though it had been obvious all along. Of course, a certain tilt of the head means peace. Of course, a lowered wing means follow me. What else could they mean? To humans millions of years later, these messages can appear arcane or inscrutable, but to the animals living them, they are as clear as the sky on a bright dawn. In this era of diversification and deepening sociality, communication blooms into something delicate, immediate, and profoundly expressive. Faces, fur, and feathers become instruments, quiet ones perhaps, but capable of conveying volumes with the smallest movement. And through these signals, early social creatures learn a truth that will echo through evolution forever. Sometimes the most important things are said without a sound. Signals are no longer fixed. Individuals learn calls, modify them, invent new variations. Communication adapts within a lifetime, not just across generations. Gentle humor. At last, evolution allows improvisation. Results may vary. Once brains grow intricate enough, layered with memory, pattern recognition, and curiosity, communication begins to loosen its boundaries. The fixed rhythms of older species give way to something more fluid, more creative, and astonishingly adaptive. Birds and advanced mammals, with their increasingly complex neural circuits, step into a new realm where communication is not only inherited, but acquired. It can change with experience. It can evolve within a single lifetime. It can even, on occasion, be invented on the spot. This shift marks one of the most transformative chapters in the story of communication. Until now, messages have been crafted by anatomy and instinct. A call shaped by vocal organs, a signal etched into a species' behavior through eons of selection. But with the arrival of learning, true learning, communication becomes flexible, local, nuanced, and deeply personal. Birds lead the charge, especially those whose brains develop specialized regions for vocalization. Young birds hatch into a world filled with sound. The calls of parents, neighbors, rivals, and distant kin echo through forests, coastlines, and grasslands. Yet they are not born knowing these songs. Instead, they listen, experimenting with imperfect imitations. Early attempts are soft, tentative, and often rather unsteady, much like a child testing the edges of language. Slowly, through practice and repetition, they refine their voices until they match the patterns around them. But matching is only the beginning. With social interaction comes variation. Birds begin to tweak the melodies they have learned, stretching a note here, softening another, rearranging phrases in ways that catch attention. Entire dialects emerge. One valley sings in slightly different patterns than the next, and members passing between them carry bits of both traditions, blending and reshaping them. Communication becomes geographically textured, like an ever-changing cultural map in song. Among mammals, the same flexibility arises through vocal and behavioral learning. Young individuals gain their social signals not by instinct alone, but by watching and listening to elders. A juvenile may struggle at first to produce the right vocalization or perform the appropriate display in a given context. But through trial, feedback, and observation, it hones its abilities, learning not only what to communicate, but how to adjust that communication depending on who is listening. Advanced brains allow animals to recognize subtle differences in context, whether a situation calls for urgency or calm, formality or playfulness. They modify tone, gesture, and rhythm depending on audience and circumstance. This level of modulation gives communication a new quality, flexibility. It is no longer a rigid, hardwired response, but an adaptive tool that can shift moment by moment. The emergence of improvisation is especially striking in species that live in fluid social groups. Individuals must navigate ever-changing alliances, hierarchies, and relationships. In such societies, the ability to creatively adjust signals becomes a powerful advantage. Animals craft unique calls for specific partners, alter their tone during conflicts, or soften their displays to reassure group members after tension subsides. Some begin to develop signals that convey intention rather than emotion, hinting at what they plan to do, not just how they currently feel. In birds, improvisation blossoms into remarkable displays of vocal art. Some species integrate sounds from the environment, wind, water, even the calls of other species, into their songs. A forest becomes a place where creativity echoes, each generation weaving new threads into the acoustic tapestry. Young birds learn not only from parents but from peers. They borrow, adapt, and occasionally embellish until their songs become signatures as distinct as fingerprints. Mammals, particularly those with strong social bonds, develop their own improvisational tendencies. Mothers craft unique sounds for their offspring, gentle murmurs or rhythmic pulses that only a particular youngster responds to. Individuals create specific calls used exclusively with particular companions, strengthening relationships through personalized communication. In cooperative species, signals evolve that coordinate group actions, allowing fluid teamwork during hunting, foraging, or defense. This flexibility also allows communication to respond to shifting environments. When new predators appear, animals invent new alarm calls or modify existing ones to better distinguish threats. When habitats change, dense forests giving way to open grasslands, the soundscape shifts, and communication shifts with it. Calls that once bounced between trees adapt to carry farther across wide spaces. Behaviors that once relied on cover adjust to be visible from greater distances. Learning brings with it another profound breakthrough: imitation. Some species begin not only to modify their own signals, but also to mimic the signals of others, sometimes to blend in, sometimes to deceive, and sometimes simply because their minds are curious. While mimicry serves different purposes depending on context, its presence reveals a striking truth. Communication has become a playground for experimentation. But with great flexibility comes great risk. Improvisation, while creative, is unpredictable. A new call designed with the best intentions may be misinterpreted. A gesture meant to soothe may accidentally provoke. Social animals now must navigate not only the complexity of communicating correctly, but also the challenge of interpreting innovation. Yet evolution embraces this risk because the rewards, adaptability, nuance, resilience, far outweigh the occasional misunderstanding. Over generations, the capacity to learn and modify communication becomes a hallmark of intelligence. It fosters cooperation, deepens bonds, and allows cultures, true cultures, to form in animal societies. Not just behaviors passed genetically, but traditions carried through memory and teaching. And evolution, ever amused by its own inventiveness, finally allows improvisation. The results, naturally, vary widely. Some individuals become virtuosos of vocal expression. Others attempt creativity and produce noises best described as enthusiastically experimental. But even these imperfect improvisers contribute to the rich, evolving fabric of communication. In this era of learning, communication is no longer a fixed script. It is a living, breathing art, shaped by experience, honed by memory, and reinvented with every new voice that enters the world. Behaviors spread through observation. Alarm calls become specific. Young learn not just what to do, but when and why. Communication begins shaping culture. Soft humor, survival improves dramatically once everyone gets the memo. As social species grow more sophisticated, an extraordinary shift takes place. Knowledge begins to move not only through genes or instinct, but through teaching. Not teaching in the human sense, with lessons and lectures, but in the quiet, embodied way many animals pass wisdom to the next generation. By doing, showing, gesturing, pausing, waiting, and correcting. It is one of evolution's most elegant inventions, the ability for experience to leap from one mind to another. This shift begins with the young. In many early social groups, newborns enter a world too complex to navigate by instinct alone. Predators lurk, food sources vary, seasons change, and social hierarchies grow intricate. Simply knowing what to do is no longer enough. One must know when to do it, where to do it, and why it matters. To solve this challenge, species begin to rely on the power of observation. Young animals watch their elders with astonishing intensity. They track every footstep, every glance, every subtle shift of posture. They become apprentices in the art of survival, not through words, but through immersion. The earliest evidence of this appears in foraging strategies. A youngster may know instinctively that certain plants are edible, but it learns which are best, when they are ripe, and how to access them by watching elders interact with the landscape. Adults peel bark, dig at soft soil, or crack shells, and the young copy them with varying degrees of success. At first awkward, then capable, eventually adept. This kind of learned behavior spreads through groups like a quiet ripple. One individual discovers a new technique, a safer path up a rocky ridge, a better method of extracting insects from wood, a clever way of avoiding a thorny plant. And others adopt it simply by watching. Some innovations vanish quickly, others persist, weaving themselves into the behavioral fabric of a species. These lasting habits, repeated across generations, become the earliest forms of animal culture. Traditions born not from instinct but from shared experience. Communication evolves to support these subtle exchanges. Signals become more contextual, guiding young individuals through complex tasks. A parent might emit a soft sound to encourage a juvenile to stay close while navigating dangerous terrain. A flick of the tail might mean pause, while a gentle nudge conveys try again. None of these gestures are standardized across species. Each lineage develops its own set of cues, shaped by ecological pressures and social dynamics. Alarm calls also gain specificity. Earlier in evolutionary history, alarm signals were broad bursts of tension, general warnings that danger hovered nearby. But in species with strong social bonds, these calls become increasingly precise. A sharp, abbreviated call might indicate a predator approaching from the ground. A different tone or rhythm may signal an aerial threat. Still, another version may warn of danger that is near but unseen. Each variation triggers an appropriate response: hiding, fleeing, grouping tightly, or climbing to safety. Young animals learn these distinctions not by instinct alone, but by observing how adults react. A chick hears a particular call and watches its parents flatten against the earth. A juvenile mammal hears another warning and sees the group bolt toward the nearest shelter. Over time, it internalizes not just the meaning of each signal, but the exact actions that follow. Understanding the alarm is good. Understanding the appropriate response is survival. This learning extends beyond danger to include the social rules that bind groups together. Dominance hierarchies, cooperative tasks, and relationship maintenance all rely on behavior learned through observation. A young member of a primate group, for instance, watches how adults offer reconciliation after a disagreement. Gentle touches, mutual grooming, shared proximity. It also sees how conflicts escalate when signals are ignored or misinterpreted. In these practices, it learns the subtle art of social negotiation. Teaching becomes more intentional over time. Adults slow their movements when youngsters are present, giving them time to study. They repeat actions, demonstrate tasks, or modify their behavior to make lessons more observable. This doesn't mean they decide to teach in any conscious sense. Evolution simply favors individuals who help their offspring absorb essential knowledge. Those offspring survive more reliably, and the tendency to facilitate learning spreads through the population. Some species even develop mentorship roles within their groups. Older siblings, still inexperienced themselves, practice guiding younger ones. They lead them to safe foraging sites, gently discourage risky exploration, and demonstrate how to interpret the group's signals. These interactions strengthen group cohesion and ensure that important knowledge does not bottleneck through a single individual. Over generations, this shared learning gives rise to distinct cultural variations. Two populations of the same species may live in similar habitats, yet behave differently because each group has inherited its own traditions. One group may prefer a particular foraging route. Another may favor a different mating display. A third may develop unique calls that differentiate local identity. These differences are not genetic. They are learned, taught, passed along like heirlooms crafted from memory. With communication now shaping culture, social groups become resilient in new ways. They can adapt to sudden changes, new predators, new food sources, shifting climates, by collectively updating their behaviors. Knowledge becomes a communal resource, stored not in the genome but in shared experience. Innovation spreads quickly, and mistakes fade gently through forgetfulness. In this era, survival no longer relies solely on the strong or the swift, but on the attentive, the observant, and the socially attuned. Those who get the memo, so to speak, navigate the world with greater confidence. And those who learn to help others understand it create something deeper than instinct, a community bound by knowledge, shaped by communication, and carried forward by the delicate art of teaching without words. Signals evolve rules. Honesty is enforced by consequences. Deception appears but carries risk. Communication becomes an evolutionary negotiation between trust and advantage. Gentle humor. Lying works until everyone starts fact-checking. As animal societies grow more intricate, communication becomes a balancing act, a delicate negotiation between truth and strategy. Signals now carry weight. They influence decisions, shape relationships, and direct group behavior. And when messages matter this much, a new evolutionary tension rises from the depths, the tension between honesty and deception. In earlier eras, signals were largely reliable because they had to be. A weak creature that inflated its body or flashed a warning pattern was being truthful. Its size or toxins were genuine results of its anatomy. But in societies where communication shapes hierarchy, cooperation, and survival, the stakes shift. Now, an individual may benefit from exaggerating strength, masking vulnerability, or hiding intention. Thus emerges the ancient art of dishonesty. Biological, behavioral, and entirely unintentional in motive, yet profoundly effective. The first deceptions are simple. A creature might produce a threat display that overstates its willingness to fight, hoping to bluff a rival into retreat. Another may feign indifference to a valued food source until the moment the competitor turns away. Some animals begin to mimic harmless postures while preparing to strike, hiding aggression beneath a facade of calm. Others do the opposite. They feign weakness to invite careless approach. Each of these tactics arises not from conscious trickery, but from instinct sculpted by natural selection. Those who use deception effectively survive more often, and so deception spreads. But deception cannot flourish unchecked. If lies go unchallenged, communication loses meaning, and social structures collapse. So evolution applies pressure in the opposite direction, shaping perceptual abilities that refine skepticism. Individuals learn to test signals, to weigh posture against context, to compare what they see with what they remember. Trust is no longer automatic. It is earned through consistency. In many social species, honesty is enforced by cost. A signal becomes reliable only if it is expensive enough that cheating is rarely worthwhile. A vivid display might require energy to produce or maintain. A call announcing strength might demand stamina that weak individuals cannot fake. A ritualized challenge might expose bluffers to momentary danger. These costly signals become guardrails that prevent deception from overrunning the system. Consider a creature whose bright coloration indicates a robust immune system. Producing those pigments drains resources, a genuine investment. Only individuals in good condition can afford the display, so the signal stays honest. Or imagine a mammal whose territorial advertisement requires lengthy howls or repeated displays. Only those with time, energy, and confidence can persist through the full performance. Bluffers falter early, revealing their misrepresentation. But where there are rules, there are always loopholes. Some species exploit ambiguity. A bird may produce a call that sounds vaguely like one of a stronger individual, causing rivals to hesitate just long enough for the imposter to escape. A primate may position its body to hide subtle signals of fear, projecting confidence it does not truly possess. Insects might mimic the scent marks of others to slip into territories unnoticed. Each deception is a gamble, beneficial if successful, disastrous if exposed. Social animals, however, are not passive recipients of trickery. They learn. They monitor patterns and track inconsistencies. Some develop reputations, trusted individuals whose signals are taken at face value, and unreliable ones whose behaviors invite suspicion. In many species, memory becomes a powerful tool for detecting deception. An individual that repeatedly misleads the group may find itself ignored, excluded, or challenged more intensely. Trust becomes a social currency, and deception a risky investment. In cooperative societies, dishonesty takes on even more complex forms. A member might give a false alarm call to scatter the group and monopolize a resource. Another may pretend not to notice an approaching threat, hoping someone else will bear the responsibility of alerting the colony. But such tricks rarely go unpunished for long. If the group detects a pattern of selfish signals, consequences emerge. Reduced access to shared resources, loss of social standing, or decreased willingness of others to assist during conflicts. Honesty, when reinforced by social dynamics, becomes not just a moral ideal, an irrelevant concept in nature, but a practical necessity. Cooperation requires trust, and trust requires consistent, predictable communication. Signals that convey reassurance, submission, or partnership evolve to be unmistakable, minimizing confusion. Animals refine gestures that soothe tension, easing conflicts that might otherwise escalate. Within this framework, honesty stabilizes group life, even though pockets of deception persist like weeds in a well-tended field. But deception is not purely negative. It can spark innovation. Species develop new signals to counter old tricks, new strategies to weigh credibility, new behaviors to evaluate intent. This back-and-forth escalation creates a dynamic equilibrium between honesty and deceit. Evolution uses this tension to fuel complexity, shaping minds that are increasingly adept at analyzing and responding to others. Some species even develop meta-signals, behaviors that mean, essentially, I am telling the truth this time. These might include repetitive displays, intimate contact, or calming gestures that lower suspicion. Such meta-signals, while subtle, help maintain social harmony by reinforcing reliability when it matters most. The interplay of honesty and deception also pushes animals to become better at reading body language, tone, and timing. A slight delay in response, a shift of weight, a subtle pause. These cues may reveal more than any overt signal. Social species sharpen their attention to these micro-gestures, developing perceptual skills that border on intuition. And through it all, natural selection maintains a balance. Too much deception destabilizes society. Too much blind trust invites manipulation. The most resilient species find themselves in the middle ground, crafting communication systems flexible enough to handle nuance yet sturdy enough to resist collapse. Thus, in this intricate dance of truth and trickery, communication becomes a negotiation, a delicate, ongoing dialogue between what is conveyed and what is believed. It is an arms race of wits, an exchange built on both vulnerability and resilience. And evolution, watching quietly from the wings, seems to smile at its own handiwork. After all, lying works beautifully, at least until everyone starts fact-checking. Symbols emerge, sounds or gestures that stand for ideas rather than states. Communication stretches beyond the present moment, allowing planning, memory, and shared imagination. Soft humor. Evolution finally invents meaning and immediately complicates everything. As the minds of late hominins and other intelligent species grow increasingly layered, communication undergoes a transformation that is as subtle as it is revolutionary. Up to this point, signals have conveyed states: fear, readiness, attraction, submission, curiosity. They have coordinated movement, settled disputes, organized social roles, and relayed danger. But now something unprecedented stirs behind the eyes of these evolving creatures: the ability to let one thing stand for another. This is the birth of symbols, not painted symbols that will come far later, but internal ones, sounds or gestures whose meanings no longer depend solely on emotion or context. Instead, they begin to represent objects, actions, and eventually ideas. For the first time in Earth's long history, communication gains the power to transcend the immediate moment. The spark of this change appears in the minds of advanced hominins, whose brains have grown dense with memory pathways, problem-solving networks, and an increasing sense of social complexity. Their lives require anticipation: where to find food tomorrow, what direction a herd is migrating, where the safest shelter lies when storms approach. Survival now depends not only on reacting well, but on predicting well, and predictions require shared understanding. Early symbolic communication begins simply. A particular sound, repeated consistently, becomes associated with a distinct object in the world: a stream, a certain fruit, a familiar path. At first, these sounds are crude markers, as close to instinct as to language. But gradually, as individuals hear these repeated associations, they begin using the sounds themselves to evoke the object, even when it is not present. A gesture might come to mean follow, even if no immediate threat or reward exists. A sound that once accompanied a movement becomes detached, floating free as a standalone idea. With each new association, communication gains a longer reach. No longer does it merely reflect the present. It can now describe what was or what might be. Memory becomes communicable. Expectation becomes shareable. A hominin who has found new shelter can signal its existence to others without physically guiding them. A group can coordinate a hunt before prey appear. A scavenged object can be referenced after it has been hidden or consumed. In this subtle but profound shift, communication begins to weave time into thought. Other intelligent species follow parallel paths. Certain birds use learned calls, not just for identity or emotion, but to refer to specific predators in nuanced ways, effectively labeling different dangers with distinct sounds. Some marine mammals develop signals that label objects or individuals, allowing them to call to one another across distance with remarkable specificity. These early symbols do not form sentences, but they form the seeds of naming, categorizing, and conceptualizing. Memory becomes a shared resource. A gesture made today recalls an event from yesterday. A sound uttered now points towards something miles away. This ability to move information across time and space reshapes social life. Groups begin to build collective memory, knowledge held not by individuals alone, but by communities. Where to find seasonal foods, how to navigate migration routes, where dangers lie hidden, all are preserved through symbolic cues. These cues become anchors of social identity, binding groups through shared experience and shared meaning. As symbolic communication grows more sophisticated, imagination takes root. A gesture might evoke not only a real object, but a hypothetical one, an imagined predator, a planned shelter, a tool that does not yet exist. Minds capable of imagination begin using symbols to discuss possibilities, not just realities. Scenarios can be weighed, alternatives considered, outcomes predicted. Planning becomes collaborative. The future becomes a topic of communication rather than a silent unknown. Inevitably, symbolism complicates everything. Interpretation becomes less straightforward. A gesture that once reflected an obvious emotional state now carries layered meaning, and meaning can shift depending on who sends it or who receives it. Shared vocabulary must be maintained. Misunderstandings multiply. The same sound may represent slightly different nuances in neighboring groups, leading to subtle communication barriers. What one population considers a gesture of friendliness, another might interpret as impatience. The symbolic world is powerful, but fragile. Yet the advantages continue to outweigh the confusion. Symbols allow cooperation beyond immediate perception. They allow groups to store and transmit knowledge, blending individual memories into a collective intelligence. They allow bonding over shared narratives, accounts of hunts, storms, migrations, or encounters with rivals. Even rudimentary symbolic storytelling strengthens cohesion, embedding lessons in vivid recollections. As symbolism spreads, communication becomes a tool for sculpting social norms. Groups begin to reinforce behaviors not just through action, but through shared meaning. A gesture might come to represent approval of helpful behavior. Another might express disapproval of reckless actions. Through symbols, societies begin to define themselves, not just as collections of individuals, but as communities guided by ideas. This symbolic capacity also enhances teaching. Adults use specific gestures or sounds to guide young individuals through difficult tasks. These cues no longer reflect emotional tone alone. They structure learning itself, pointing attention toward important steps, reinforcing successful attempts, and highlighting mistakes. Knowledge is passed with increasing precision. Among hominins, symbolic thought takes on its most astonishing form: abstraction. A gesture might refer not only to food over there, but to more intangible concepts, like sharing, danger, safety, or belonging. Abstract ideas require a mind capable of linking symbols to invisible qualities, and once this capacity emerges, an entire universe of communication becomes possible. Shared imagination, a feature once confined to solitary minds, blossoms into a communal phenomenon. With the advent of symbols, the world becomes a network of meanings layered atop physical reality. Communication is no longer about reacting. It is about representing, recalling, anticipating, and imagining. The boundary between thought and expression grows thin, and the edge of language begins to shimmer on the horizon. Evolution, having finally invented meaning, quickly realizes that meaning is complicated, but also beautifully transformative. Through symbols, life gains the ability not just to survive in the world, but to describe it, reshape it, and dream within it. The documentary settles into a reflective close. Communication is framed not as a finished achievement, but as a living, evolving process, always shaped by environment, need, and misunderstanding. Gentle humor. Nature never stops talking. It just keeps changing the accent. Across the turning of ages, from drifting molecules to the first symbolic minds, communication has evolved from a quiet accident into a vast, intricate web of signals. And yet, even in the present era, with its chorus of birds, its whispering forests, its oceans full of coded pulses, its societies of machines and humans, they are all part of a single truth. Communication is never complete. It is not a final invention, nor a perfected device. It remains what it has always been, an ongoing experiment conducted by nature, continuously rewritten by every creature that participates in its unfolding conversation. The modern world is alive with voices. Some are familiar: the rhythmic chatter of insects, the resonant songs of whales, the playful squeaks of dolphins echoing through endless blue. Others are more subtle: the shade-shifting chromatophores of cephalopods forming fleeting patterns over soft skin, the chemical messages drifting from roots beneath the forest floor, the vibrations of spiders tracing delicate information through silk threads. In every corner of Earth, something is speaking, and something else is listening. What's remarkable is how many different languages ecosystems contain. Each species has carved out its own method of exchanging information, a method honed by its body, its senses, its history, and its habitat. A creature that lives in crashing surf develops signals that cut through turbulence. Another that navigates nocturnal woodlands learns to rely on faint sounds and the slightest scents. A species that glides between treetops develops visual displays visible from below, while a burrow-dwelling mammal finds that low, resonant calls travel better underground. Communication adapts because environment is never still. A habitat drenched in sunlight encourages the evolution of vibrant colors. One wrapped in darkness favors quiet pulses or scents that linger. Winds sculpt calls, water bends vibrations, mountains break signals apart and scatter them into echoes that species learn to interpret. If the world had been built differently, colder, dimmer, more silent, more crowded, communication would have followed another path. But it followed this one, shaped by opportunity, constraint, and the endless creativity of life. Even now, communication shifts with changing conditions. Climate alters migratory patterns, forcing new interactions between species that once lived worlds apart. Urban environments introduce unfamiliar noises, prompting birds to raise the pitch of their songs or adjust the timing of their calls to avoid the hum of engines. Light pollution affects nocturnal insects that once relied on star-guided cues. The conversation of the biosphere is constantly renegotiated, some signals fading into whisper, others rising into prominence. Within species, communication remains just as dynamic. Animals refine calls over generations, sometimes developing new dialects or signals unique to certain populations. Social groups adjust their signals as their structure changes. New hierarchies, new alliances, new tensions. Learning, improvisation, and cultural transmission add to the richness of each species' repertoire, ensuring that no two communities communicate in exactly the same way. Even plants alter their chemical messages based on the stresses they experience, sending more urgent scents when grazers or droughts press in. Humans, with their symbolic languages and cultural complexity, contribute another layer to this global experiment. We have created thousands of spoken languages, signed languages, written systems, and digital protocols, each with its own rhythm, metaphor, and structure. But though unique in detail, they share the same foundations laid by early life, signals that carry meaning across space and time. Whether tapping keys, drawing marks, or forming words in the air, we continue the ancient tradition of seeking connection, clarity, and understanding, all while wrestling with the same challenges of ambiguity and misinterpretation that every species before us faced. Communication also extends beyond species. Interactions across the tree of life give rise to subtle cross-species exchanges. Birds' alarm calling can alert mammals. Mammals grazing can stir insects into flight. Plants release scents that attract predators of their herbivores, an indirect plea for assistance. Coral reefs erupt in synchronized spawning events, coordinated by lunar cues that many species respond to simultaneously. Nature does not speak in isolation. Its voices intermingle, forming complex tapestries of shared signals. But even as communication becomes more sophisticated, misunderstanding remains an inseparable companion. A signal intended to reassure may be misread as dominance. A warning might be mistaken for opportunity. An animal may interpret a shadow or vibration as something it is not. Misinterpretations are not failures. They are part of the experiment. They prompt refinements, adaptations, and innovations. Without them, communication would become stagnant, locked in patterns that no longer reflect the changing world. The beauty of this ongoing experiment lies in its openness. New forms can emerge at any moment. A species might develop an unexpected color pattern that shifts social dynamics. Another might invent a new call to solve a novel problem. As brains continue to evolve, memory becomes deeper, imagination broader, and the potential for symbolic complexity greater. Meanwhile, as environments transform, species continually recalibrate their signals to fit new acoustic, visual, or chemical landscapes. In this sense, communication is a living relationship between organism and environment, between individual and group, between message and perception. It is never entirely polished, never free of noise or nuance, and perhaps that is what makes it so resilient. Flexibility, rather than perfection, has always been the secret to its longevity. So, as this documentary draws to a gentle close, we find ourselves in a world that never stops speaking. From the hum of forests at dawn to the quiet chemical negotiations beneath our feet, from the songs of migrating birds to the subtle glances exchanged among social animals, the earth is alive with expression. Every creature carries a fragment of communication's long history, each participating in the ever-evolving dialogue of life. Nature never stops talking. It just keeps changing the accent. And as long as life continues to adapt, learn, and experiment, the conversation will go on, echoing softly across the ages.